Hello, ladies and gentlemen. Today we're going to talk about the distance formula as well as the midpoint formula. You're going to need something to write with, a calculator, and your foldable. All right, for starters, we're going to talk about the distance formula. On your foldable, you should see that crazy formula. D equals the square root of quantity x2 minus x1 squared plus the quantity y2 minus y1 squared. This is a formula that we use, and it's kind of crazy, but we also present an option where you can use a coordinate plane as well as the distance formula. And on the next slide, I will show you how you could use either or. Now, it is your decision whether you would like to use the distance formula or the coordinate plane. Just know that if you use that coordinate plane, you're going to have to kind of sketch it out every single time. Again, it's up to you which one you use, but let's see how this looks then using one or the other. All right, so for starters here, we're going to start with the distance formula. We're going to use that formula to help us find the distance between those 2 points. So the first thing we're going to want to do is to rewrite that over here for us. So D equals the square root of x2 minus x1 squared plus y2 minus y1 squared. So then we're going to want to determine which one's x1 and which one's x2. Now it does not matter as long as x1 goes with y1 and x2 goes with y2. So once I've labeled those, we're just going to plug them into the equation for the proper numbers. So x2 it looks like is going to be 0. So 0 minus x1, which is 4. That is going to be quantity squared, plus y2 is 3 minus y1 is a negative 6, again squared. So now let's just do a little bit of math. So 0 minus 4 would be a negative 4 squared, plus when I have 3 minus a negative, those are going to turn into positives, so I'm going to get 9 squared. Now 4 squared is 16 and 9 squared is 81. So when I add those together, I should get the square root of 97. Now, then we should be looking for any perfect squares that go into 97, and after a little bit of trying, you're going to find that there are none that go into that. So that would be my final answer. And again, I'm going to want the square root in simplified form as my answer. But if you guys want to go off to the side and give me a decimal, the decimal here would be 9.85. So again, the square root in simplified form is going to be what I'm looking for. But if you want to leave a decimal with the square root, that works as well. So now let's look how this looks on a coordinate plane. So first thing I'm going to want to do is to plot those points. 4, negative 6 would be here, and then 0, 3 would be way up here. So if I were to plot those points then, now from here I'm going to want to draw a line connecting the 2 points, and forgive me if mine isn't the straightest, not too bad. But then once I've connected that line, I'm going to want to create a triangle. So if I create a triangle, I'm going to drop from this point straight down and then straight over, creating a right triangle. The reason I'm going to do this, again, what I'm trying to find is that distance here. And when I create a right triangle like this, if you count, you could count what the lengths of each of the sides are. So the bottom side here is going to be 4. And if I count 1, 2, 3, 4, 5, 6, 7, 8, 9, on the left side we're going to have 9. Now when I have a triangle and I have 2 sides of a right triangle and I'm trying to find the third, hopefully we're thinking that we can use the Pythagorean theorem, which is c squared equals a squared plus b squared. Again, this is the Pythagorean theorem, so if you want to write that down so you don't forget what it's called, because we'll use this going forward. So again, the c is always across from my 90, so c is going to be x squared. A and b technically don't matter which is which, so I'm going to use 9 as my a and 4 as my b. So then I get x squared, we have 9 squared, which is 81, plus 4 squared, which is 16. And when I have that, I get x squared equals 97. To solve for x, I take the square root of both sides, and it looks like my final answer would be the square root of 97. And again, we already talked about that. There is no perfect square that goes into that to simplify that down. So the distance between those 2 points would be square root of 97, or 9.85 units. So again, we have 2 different options here to solve using the distance formula, or you can use the Pythagorean theorem on a coordinate plane. All right, so now we look at example 2.
And here, again, we're going to start by using the distance formula. So we're going to designate those points. We'll start by writing the formula. So d equals the square root of x2 minus x1 squared plus y2 minus y1 quantities squared. Again, it does not matter which one you choose as x1 or y1, as long as the x's correspond with the y's. So now that I've designated which one's x1 and x2, we're just going to plug in for what we know. So x2 is 0, subtract. x1 is a negative 4 squared plus y2 is negative 8 minus a positive 2, again squared, equaling the square root. Here I'm going to get a positive, subtracting a negative, so I get 4 squared plus, in parentheses, I have a negative 10 squared. All I'm doing is subtracting the 2 from the negative 8. Here, then I would get 16 plus 100. And if I go further, I get the square root of 116. Again, I do prefer the square root answers. So if we could find a perfect square that goes into 116, we could start with the lowest perfect square besides 1, which is 4. And 4 does go into it. So if we split this up, we'd get the square root of 4 and the square root of 29. The reason we do this then again is so that that square root of 4 turns into a 2. We can't break 29 down any further, so my answer then would be 2 square roots of 29. Again, if you wanted to convert that to a decimal, you could, but again, I prefer the square root. So if we had a decimal, it would be 10.77. So now again, let's try it on the graph. We're going to start by plotting both points, so negative 4, 2. And then we have 0, negative 8. So 1, 2, 3, 4, 5, 6, 7. 8. Oops, my negative 4, 2, 1 went away. And then again, we're going to want to connect those two. Forgive me if my line isn't the straightest. Once I connect them, then we're going to want to make a triangle. So drop it straight down and go straight over. Since I made a right triangle, we're going to want to know those sides. So since I'm on a straight line, I can count. This side would be 4. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and this side would be 10, and we're going to want to find that hypotenuse. So again, we're going to use our Pythagorean theorem. C squared equals a squared plus b squared. C squared is always the one across from my hypotenuse, so that's going to be x squared. A and b don't necessarily matter which one you choose first, so we'll go 10 squared plus 4 squared. So we get x squared equals 100 plus 16. X squared equals 116. Take the square root of both sides. X is going to equal square root of 116. And again, we already did that hard work over here, that's going to break down into 2 square roots of 29. So again, either way you want to do it, using the graph or using the formula, they both should come back to the same answer. The last formula we're going to talk about today then is the midpoint formula. And just as it sounds, the midpoint formula finds the point in the middle of a segment. So here we have x1 plus x2 all over 2 and y1 plus y2 all over 2. So again, when I do the midpoint formula this time, we're going to get back an ordered pair xy because we are finding that point, the middle point. So again, we think of this as just the average of the x's and the average of the y's. So here, let's take a step forward and look at what that looks like. All right, so in example 3, again, we have this midpoint formula over here. So what we're going to do is determine which one's going to be x1 and y1 and which one's going to be x2 and y2. Again, it does not matter which one you choose to be either, as long as the x's and y's correspond. So we'll just do x2, y2. So then we're going to use our formula. So the midpoint, so the x's, we're going to add the x's together. So 1 plus a negative 2 all over 2. And then we have negative 2, which is y1, plus a positive 7, again divided by 2 because we're finding the average. So here it just becomes some mental math. 1 plus a negative 2 would give me a negative 1 over 2. Negative 2 plus 7 would give me a 5 over 2. And then here I would look to simplify. Notice here that a -1/2 isn't going to simplify any further, nor does a 5/2. Again, I don't want any decimals, so the midpoint of this segment that connects those 2 points would be -1/2 5/2. So this would be my x coordinate, and this one would be my y. So if you have any questions on that, make sure you jot that down. In our last example of the day, then, we are going to want to find the midpoint again. Again, since I'm finding the midpoint, we should get an answer back that's x comma y. So the first thing I'm going to want to do here is determine which one's my x1 and my y1, as well as my x2, y2. So we're going to start by putting the m, and then in parentheses is where we'd put all of our work. So what I'm going to have you do is finish this problem, and then when you get an answer, it should be in terms of x comma y, and we'll check that when we get to class. So I want to thank you for taking good notes, and I will see you when I see you.